All right, so these are your magnetism notes, and it's a one-sided paper. We're going to start in this box right here. So I'm going to go ahead and zoom on to that box, and we're going to be talking about magnetism. So magnetism is when iron, nickel, or cobalt become magnetic. And let's talk about how they become magnetic first. So we're going to go down to this part first, and then we'll talk about the field lines. So why does this become magnetic? Magnets are split into pieces that are called domains. So these domains are when the particles are the particles of iron, nickel, and cobalt. Or cobalt. And when they are aligned, they're magnetic. When they're unaligned, they're not magnetic. What that simply means, so if you look at the picture at the bottom, these are the domains. So this is a domain. This is a domain. And if you notice, all of the arrows are pointing in the same direction. This is because all of the electrons are spinning in the same direction. We call this aligned domains. Aligned domains. So here's where all the electrons are spinning up. So all electrons are spinning in the same direction. In our picture, they're all spinning up. All electrons spin in the same direction. Therefore, this part of the magnet ends up being the north part of the magnet. The bottom part of the magnet is going to end up being the south part of the magnet. This can only happen when you get a magnet when the domains are aligned. So for that reason, this is going to be magnetic. If you drop a magnet too many times, what can happen, or what will happen eventually, is that all of the domains are going to become unaligned. The electrons are going to spin in whatever direction they want to spin. So now we're going to have unaligned domains. Okay, so now the electrons are spinning in different directions. So your domains will no longer be magnetic. They're not spinning in the same direction. So you can have a magnet, and if you heat it, you'll lose the domains, so they'll start spinning in whatever direction. If you drop it too much, I'm trying to think what else, but I think those are the two main ones. So dropping a magnet or heating it would cause the domains to be unaligned. So this one, all the electrons are spinning this way. This one, the electrons are spinning this way. On this one, they're all spinning to the right. Okay. This one, they're all spinning down. So all these domains have different spin, and this is not going to be magnetic. Not magnetic. And I know I already said this. And this one is going to be magnetic. This is going to be the North Pole. This is going to be the South Pole. How do I know that? Let's talk about our magnetic field lines. Magnetic field lines are going to be very similar to what we've learned with electric field lines. So magnetic field lines, magnetic fields. Magnetic fields are split into the North and the South Pole. So we have the North Pole and we have the South Pole. With the North Pole, the arrows are going to be pointing out. Arrows point out. Out or away from the North. And they're going to point towards or into the South. So arrows point in or towards the South Pole. Okay, here's our picture. Notice the North arrows are pointed out, similar as our positive is out, our negative is in. North is out, negative is into the charge. So this is in one magnet, and of course they do interact, and you could see the field lines between two magnets. You're going to get to see that in lab coming up next week. The last thing we're going to talk about is the interaction of charges. This is also very similar to what you've seen before with north and south, or positive and negative charges. So same rules apply. Opposites attract, same charges repel. So this is our interaction of the poles. A different color. Interaction of poles. Opposites are going to attract. And same poles are going to repel. The drawing is also going to be very similar, except for instead of a charge like a positive and negative, it's going to be the north and the south. I'm going to draw it with two different colors here. So here's the north, here's the south. And I said the rule was out of the north and into the south. So out of the north and into the south pole is our first line. And then it's going to start curving just like the curves that we saw on the electric field lines. Okay, so we're going to flip this. The only difference between north and south when they're flipped, so this one's now the north side, this is a south side magnet. The only difference with the lines is the direction they are pointing. So still out of the north and into the south, and as you come around, these magnetic fields are actually going to push away the other magnetic fields. Okay? And when you have the same north and north, you've actually felt this repulsion, and you'll feel it on the stations lab that we do on Monday. You can actually feel these lines, and you could feel the magnet pushing away, pushing away, pushing away. And someone said, oh, this looks like eyelashes or spiders. Yes. And they are meant to come towards, but then they don't want to touch, so they push away. This one comes towards, but it doesn't want to touch, so it pushes away. This piece is where you feel that repulsion. And I'm going to draw this one with lots of lines because I'm going to tell you that this still applies. If there's more lines, then the magnet is stronger. If there's less lines, then the magnet is not as strong. So here's south and south. And let's pretend these magnets are not as strong. So the lines are still going to come towards, but they're going to push away, come towards, and then push away. But now these arrows, you have to remember, they point towards the South Pole. So it's in the direction to the south. And if the magnet doesn't have as much strength, then it's not going to have, as many lines. All right, so this is going to be stronger magnets because there's more lines. So these ones are stronger magnets because they have more lines. And a weaker magnet has less field lines. All right, and then that's all of the information you need to know for magnetism. And this concludes all the electromagnetism information that we needed to learn this week or for this unit.